Gentlemen, so what we've been doing is that inverse normal distribution. And when we do that normal distribution, what have we been finding? What did you find on all of your homework problems? When we found that normal distribution, all those values that you punched in, that value that you got back from your calculator, what was that value? Okay, what was that decimal representing? Probability, okay? That probability. The probability that your x value was in that range. Yeah. We did use the CDF when we had a range of values. We didn't have very much practice with the PDF because that's not something that you're going to really do. PDF I doubt very seriously. No, that's the thing. How do we do it? This, what I just gave you, is now taking what you did the other day and going in the reverse. Because what you had before is you were finding that probability. What we said, the area under the curve was equal to 1. The area under this curve was equal to 1. So that corresponded to probability. Well, now if we go backwards and we say, okay, now I'm going to give you the area under the curve. I'm going to give you that probability. And I'm going to give you the bounds. Now, what we're going to have to find is that x value. Where on that number line, how many standard deviations away from this starting point are we looking at? Okay? So if you look at this, now we have, I'll tell you what, I'll put it up on the screen, make it a lot easier. If you look at that number 1, number 1 says, if x is normally distributed, and what can we say about this distribution? What kind of distribution is that? Standard normal distribution. Okay? More normal. More normal than anything else. All right. So if we're looking at some random variable x that's normally distributed with a mean of 0 and a standard deviation of 1. Here we go. So we're looking at a standard normal distribution. All right. Now here you notice that I give you the probability. This is what we found last time. This is what we were finding. That probability. All right. Now because I give you the lower bound, I give you the upper bound. We punch that into the calculator with the standard deviation and the mean, and we got back this probability. Now, I'm telling you here is that probability. Find that x value that goes right there. What is that value that is right there? Right? So in other words, find that a value. Last time I gave you that boundary value. Now we're going backwards. The only difference is now we're using the inverse norm. All right? So we go to the exact same calculator function, and it's right below your normal CDF. And it's the inverse norm. Right? So if you go second bars, yes, or every yours is going to be the same. Area is that probability. Okay? So remember, this probability, the probability that we found is synonymous with that area. Okay? Okay? So now, when we go to the inverse norm, instead of the lower bound, upper bound, mean, and standard deviation, what are the 3 things that we have to put in for our inverse norm? Area. What's the next one? Mean. in standard deviation. So what's the area here? 0.88. What's the mean? 0. Where'd you get that from? From our symbolism. And our sigma is 1. So when I punch this in, we get an A value of what? No, that's an equal sign. Okay? Remember, you can't have a negative probability. 1.17? Okay? And again, remember, let's start to get into the use of using that 3 sig figs. All right? And that's it. All right? Pretty straightforward. The only difference is now we're going in the reverse way. We give the probability, trying to find the x value. Before I gave you the x value, you were trying to find the probability. All right? So go for the next one. Do number 2.
Is the thing you
I will give you a hint if you're working ahead. For these inverse norms, it is very useful to draw a sketch. Okay? It's very useful to draw a sketch. We didn't have to draw too many sketches when we were dealing with the just normal distributions, right? Because it was kind of straightforward. Where are your boundaries? Put them in, bang, bang, bang. But now, especially with a problem like number 4, it is very helpful to draw that sketch, to figure out which way I'm tailing off. Now, also, be careful, because remember way back when we started this, not way back, the other day when we started this, feels like way back because it's a break, but when we started this, what did I tell you about your calculator? Your calculator calculates which way? All the way to, always to the left. Always to the left. Okay? So be careful. This is why a sketch is very important. Your calculator calculates the area to the left of the boundary. It will not calculate to the right. So what do we get for number 2? 0.389? 323? 385. What was your area?
0.65.
0.65.
What?
0.6. It's greater than. So like I said, be careful. Your calculator calculates to the left. This thing is not to the left. Okay? We have an area, right? We have a distribution, and we have the normal, standard normal, and we're looking at a value that is greater than. Okay? Now, it's 0.65. Let's think about this. Which side of my mean is 0. Or how much am I going to get as 0.65? Right at my mean, to the left and the right of my mean is how much? How much area is to the left of my mean? 50%, 0.5. How much is to the right? 50%, 0.5. So I've got this value that is greater than my B is 0.65.
So do you make it negative?
So if this is 50, I know it's going to be somewhere in here, but it's going to be greater than. What side of that line am I shading? To the right. What side does my calculator calculate? To the left. How much area is to the left of that? What?
0.35.
How'd you get 0.35?
Just minus 8/1.
Why 1?
Because that's
Because the area under the curve is always equal to 1. All of this area is equal to 1. All the probability is equal to 1. But when I want to calculate, I always have to make sure that I'm setting my calculator up to calculate to the left of that boundary. We want to the right. So what probability, what area do I have to tell my calculator to calculate? Well, I got to calculate the stuff to the left. I want this stuff. Well, this stuff, we know that over here is 0.65 because that's what's given. That means that this side that I gotta put in my calculator is how much? 1 minus 0.65, which is 0.35. Be careful with that.
And that's your area?
That's the area that I put in, right? You must pay attention to this all the time.
And you only do that, wait, they are asking for it on the right.
Yes. If we are looking for the area that is to the right of the boundary, we must subtract that area from 1 because my calculator does not calculate to the right. My calculator calculates from the lower up to that value. Yes.
So we don't do the 1 minus 0.65, like maybe is.
When we're looking for it, when we are looking
When it's.
for the value that is for the to the right. So where my B value is the lower bound, is the less than part. So yes, B is less than that X or A or whatever that value variable is. Okay? When it's like this, when I'm looking for my random variable that is less than or equal to that boundary, then I just put that probability in. But when I'm looking for that random variable that is greater than that boundary, I just subtract that from 1. Okay? Now, what's the difference between 1 and 2 and number 3? This is not a standard normal distribution. Does that change anything? Yes. The only thing that changes is my mean is no longer 0, it's 5. My standard deviation is not 1, it's 0.6. Everything else stays the same.
It'll be 0.63.
Yes, for number 3, the area that I want is 0.63 because again, we're looking at greater than. Okay? Anytime we're looking at greater than, I need to subtract it from 1. So my area that I really concentrate is 0.63. What's my mean? And my standard deviation? 0.6. So what is the C value? 5.2?
Well, if it's 360.
I don't know what it's looking like.
It's 5.19, but then there's another 9.
Wow. Let's look at that, 5.199, okay? This is a great question, all right? 3 significant figures, 1, 2, 3. I gotta look at that guy, because that guy dictates, well, this is a 9, so what happens? It goes up, so it makes this a 10. Well, if I make this one a 10, it goes 0, but I gotta bring one over there, so it's 5.2 or 5.20. Either one of those is fine. Yes.
What is the answer?
Oh, we didn't get the answer. What was the answer for number 2?
-0.3.
Oh, negative.
Is that
Oh, wait a minute.
It's the boundary. Yeah.
Sorry. What do we get?
Negative 0.35.
Negative 0.385? Do we get that? I don't know. I don't trust you guys. I don't have these answers memorized. Yes.
When you're doing that, can you explain how you got 5.19?
Sure. All right, so let's see. Five.
Yeah.
Alright, you guys got like -0.385. Alright. One time I trust you.
You're welcome.
Alright, so for number 3, you said? Alright, so for number 3, we have again a greater than. So I don't use this probability. I'm gonna take 1 minus the 0.37, or 1 minus 0.37 is 0.63. So then I go to my inverse norm,
And then you put 0.6.
and then I put the 0.63 in. And now, instead of the mean being 0, my mean is 5. And instead of the standard deviation being 1, it's 0.6. And then I get 5.19911. Okay? Now, number 4. Knowing what we know and doing what we've done for 1, 2, and 3, see if you can get number 4. Number 4, there's a little trick. Be careful. Yes.
D here, and then that's your area, you get D from here.
So we have to minus. Do something with that.
And that was the equation. It's like this,
Whatever this is.
oh, but it's less.
You subtract it from whatever the area is, and then you. And then you just. Then you put 1 minus 0.6 and then
Yeah,
0.
Yeah.
Do we get D and E yet? Wait, okay.
Oh, yeah.
That's right.
Subtract 1 from 0.37. What's 1 minus 2?
I don't know what I'm saying. This peak, just keep that. Right.
Yeah.
Is it more up?
Got it.
I said
More up.
You can say,
Is it more up?
is it greater than that one or like less?
something.
You got something, so.
And then we're not quite sure. So it's like, would it be
How do you do these?
like solve? Would it be the boundary the smallest
So biggest boundaries and. We have this from my office.
Yes, but then what?
How many guys got D? What is it? That one pretty good, 14.2. Three significant, three did 14.2. How many guys are having trouble getting E? How many guys drew a picture? What did I tell you about that picture? It's gonna help. Now, why? Because when I put that in, when I look at D, I'm looking at a probability that is 0.1. That's somewhere around in this area. Okay? That's way down here. Right? So my line, that's where D is. Take these out so that it's not as confusing. Not so much going on in there. Okay? Now, I know that E is somewhere such that the probability, the area between D and E is 0.72. Well, between, to the right of D, but to the left of E. So E, well, wait a minute, it's 0.72. What side of 17 is 0.72 going to be? It's going to be on the right side. I don't know where, but somewhere we can estimate. Okay, well, if I shade that way, let's shade this way. That's this. That's E. How does my calculator calculate? To the left. What's to the left?
Infinity.
Would you add them to? Would you plug it in and then add 14.2 plus
14.2.
0.1?
I would add these two areas. Because my calculator calculates this whole area to find E. But this probability that I've given this area, this part is only 0.72. This part is 0.1. I want this whole area that is to the left of E. Well, how much area is to the left of E? 0.1 plus 0.72. 0.8.
So that's
19. So that's the area that I put in for E. So then, if I take that area, put it in, with my mean of 17, standard deviation of 2.2, so we get D is equal to 14.2, then E is going to be what?
19.0.
19.01, but that's four significant figures. So we could just say 19.0 or just 19. Great. Yes.
Like, why do you have to add them?
Because this, I can't put a lower bound on this. My calculator calculates everything to the left, all the way down to negative infinity, when we're doing this inverse rule. All right? So here, the probability that I'm given, this 0.72, isn't all the way down. It is only from here to there. That's only that 0.72. Well, everything to this side is that probability of D. Well, that's 0.1. So if I have this area in here, which is that 0.72, I have to add in this part, the second area. 0.72.
And you do that for all of them?
Well, I do it if I ever have this situation like this again.
And if you, instead of having a D, if you had D up there and D down here, do the same thing.
If these two variables were switched, yes. Okay? All right, so now you've seen all the different types of inverse norm problems that you will see. You're gonna see a standard distribution, you're gonna see a general distribution, and then you're gonna see a mix of just one particular point, and then you're gonna see them when you get a band. And it's not all the way down to the left. And you're gonna see greater than instead of less than. In these 4 problems, you've seen all the different types of inverse norm problems that they can throw at you on this exam. Okay? Now, the good ones, the word problems. All right? Take a look at old Bernard at number 5. Bernard. That was the coolest thing when I was in middle school. Gene Chaplin. All the Gene Chaplin, 2 or 3 pockets on the inside.
Really good about this. No, it was
All right. So, in some certain year, Bernard estimates that 5% of his lambs, he's a lamb herder, have not reached the required mass for market. The mean mass of the lambs this year is 38 kg, and the standard deviation is 2.85 kg. Was the minimum mass requirement for his lambs to be sent to the market this year?
This is still in.
Because that's a, it's 5%. So
So the mean is 30.
Oh.
The mean.
What did you?
Next, 0.09.
Keep in mind, what are we looking for here with Bernard? We're looking for a probability or we're looking for a boundary? We're looking for a boundary. So when we look for a boundary, which one do we do? Inverse one.
Oh, yeah. Here's the matter. What is wrong with you? Too low. Maybe that's too low. Where's it wrong?
So the area is 0.05.
I got 1 point. No, that's close.
So no, that's. I'm sure you're used to it.
What did you
Just
get?
calculate her problem. Sort of
Okay, we had a chance to find this weight.
Yes.
What's our area? 0.05. Where'd you get that from? That's the percentage. The percentage can be converted into a probability. Probability is the same as the area.
That makes no sense at all.
So if that's my hidden area, my area is equal to 0.05. My mean then is 38 in my problem, and my standard deviation, 2.85. When I do that, I get a minimum mass that he needs to have, or his lambs need to have, of 33.3 kg. Yes.
So with the standard deviation of 2.85, we don't have to worry about square rooting that?
No. Good question. Okay. This is a question that came up yesterday with the other class. For the 2.85, the standard deviation, 2.85, no, we don't have to worry about square rooting that, because remember, when it's written this way, this 2.2 is my standard deviation, right? When it explicitly says the standard deviation is 2.85. Now, if it says something about the variance, then that's when I have to do that, right? I can't remember where you would see a problem with that. They normally, if you're working a problem like this, it's on the standard deviation. Okay?
I got it wrong because I didn't add. It was 0.05. But now I have to add 0.05.
There you go.
That's what it is.
No.
It should be.
Wait, it said 5%.
Maybe two different answers.
No.
Yes.
Normal PDF.
It's right there.
I know he did it wrong.
It's right there.
Should have put a wager on it, shouldn't I? Okay.
You're so good. I don't know.
I'm doing my water last one.
All right.
Is it tomato one?
Tomato farm. Oh, you're jumping ahead. That's good. All right, I'm gonna throw AISD out there. The masses of the teachers here at AISD are normally distributed with a mean of 65 kg and a standard deviation of 9.3 kg. This is completely made up. I don't know what they are. But we're gonna pretend. All right? So what's the probability that I have a mass of more than 75 kg?
This is normal skin.
What's that?
Is it not inverse for A?
Why is it not inverse?
Because they ask for probability.
Exactly. Excellent job. Good reading. Okay. When they ask for a probability, we do not use the inverse. When they ask for a probability, and I try to throw this curveball at you on purpose. When they ask for a probability, you don't use the inverse. We use the just regular, normal distribution. Good catch. Oh, tomato one or?
Yeah.
Interesting.
Red, Raven. Yeah.
I also use this.
That's why they call it ball bag curve.
It's only 10%.
Oh, okay. Well, it's
This
like
is
saying.
10% lower, so you, upper bound,
Yeah.
like 0, 1.
Is it actually?
One, one, zero. So you find that.
Yes.
To me, like, I didn't
No.
say it. The rest of them, I think you saw
Okay,
that.
temperature drop, it's not cold.
Sorry, Tom here.
That's funny. Okay, so we got that probability. Good job. Normal PDF or normal CDF?
That's normal.
Normal CDF, okay? More than, we're getting a rate. If it said exactly 75, then we know it's PDF. Here. Okay, but we're looking at a range, so we go a CDF. Now, part B. 80% of teachers have a mass of less than m kg. Determine the value of that m. Now we're looking at a percentage. Now we're looking at a probability. Now we can use the area. Now we use what function? We're looking at a position where we give the probability. Which function do we use? Inverse norm. And another giveaway is another way to look at this. When you're looking for a probability, normal CDF or PDF. When I'm looking for an actual value, inverse norm. All right, did we get it?
So. We get this part.
We got it.
Oh, that's fine. Oh, yeah, we already got it.
it.
Alright, so this is 93, so lower. So 90, upper bound is finished. And then we get this. I just go Mexican.
What do we get for M? 72.8, 72.8. We got two takers for 72.8. 3? All right. Must be verified. It is 72.8 kg. All right. Mr. Ramirez and tomato farmer, I'm gonna leave that for your homework. All right. I will give you a hint for the tomato there, for Mr. Ramirez and his tomato. Draw a picture, refer to problems number 1, 2, 3, and 4. I must have hit.
We did a picture, it doesn't want.
Did you do it right?
Yeah.
Oh, that's it. Part of it.
My dad.
Yeah. So the meme is 160.
Okay. Now, yes, your tomato problem, part of your homework. Now, what we're gonna do now is we are going to go to the last part of our distributions, right? So we're gonna finish up distributions today, Sunday, here we go. Sunday, we are going to get into our logic and our logic and conditionals. So we'll finish up distributions today, we'll do logic and conditionals on Sunday, then we're done with those things. I might have a slight little quiz on Tuesday on those, won't be a big assessment, might be 1 or 2 problems, one of each day. And then we're going to, for the rest of Tuesday and then Thursday, what we will do is we'll finish up area, two-dimensional, three-dimensional area volume, and any oddball functions. Shouldn't be too many. I think you guys covered most of them last year. And then that leaves 2 weeks in January, the last 2 weeks in January, that we can concentrate on filling in any of those loose gaps and starting, if not hopefully, finishing calculus. Yes.
Just a question on the quiz on Tuesday, what would it be on? Would it be on this?
It'll be on the normal distributions, inverse normal, and then what we'll do on next time. I've got a feeling right now, I don't have confirmation on this, I think your mock exam is that Monday, and you'll have the paper 1 in the AM and paper 2 in the PM. Whatever the board date is. Something like that, 14, 15, happy Valentine's Day, take an exam. Love ya.
Wait, and this would count as a meeting?
I don't know how it counts. This is not an ID.
So it could shop our entire lab.
Could, very well. All right. Now, the very last part, and I need your attention because this actually is the most confusing and is, out of all the distributions, the actual hardest part. Obviously, what we've done at this point is a bunch of number punching, kind of mindless monkey games, just figuring out which one to use and which numbers to put in. This one's a little bit more difficult because what we are going to do now is we are going to take a normal distribution, we're going to standardize it, right? We're going to take a normal distribution, any normal distribution, and we are going to put it into a standard normal distribution. We're going to change it so that the mean is 0, standard deviation is 1. And then that way, the reason that we do that, and the reason that this is done outside of just this class, is that once you standardize all these things, it doesn't matter what you're looking at, it's always going to be based around a mean of 0 and a standard deviation of 1. So I standardize all these values, and I can compare all these different things, I can put them into a single comparison. All right? Now, give you an idea, it's a little bit modified, but what you guys might relate to is your SATs. All right? Colleges standardize all of those, and then they put you guys, when you submit your stuff, your score is standardized, and then put into, okay, you are 1 standard deviation above or below, 2 standard deviations above or below, you're half a standard deviation above, you're 0.3 standard deviations below the mean, you're at the mean, wherever you are, okay? That's how they compare students, all right? They don't necessarily look at exact values. Some do, all right? Some do, because they have that minimum, all right? They have that minimum, whatever, 1,800, 2,000, whatever their minimum is, and then you have to go from there, all right? As a matter of fact, I think on your SAT, when you get your results back, they give you a standardized score where you are. I'm not positive they still do that. Okay. I thought they did, but I wasn't sure if they still did. All right, so when we're looking at this, we're going to standardize the normal distribution. So, to start off, quickly, sketch a graph of this normal distribution, which is not standardized.
I have it.
How do I sketch a graph of that?
Just.
Just make,
Yeah.
You can.
or not,
What?
just make it curve.
Okay, make your curve.
and you know that the mean is 2.
So where's that go? In the middle. So I know right here in the middle, that's 2. Now what?
Go on by 0.5.
Go up. So 1 standard deviation above is 2.5. 2 standard deviations above is 3. And then 3 standard deviations above is 3.5. Then 1 standard deviation below.
1.5.
All right, 2 standard deviations below.
1.
And 3 standard deviations below.
1.5.
0.5. Okay, so there's your sketch. Now, if we want to standardize this thing, so I want this 2 to become a 0. How do I get it to do that? You subtract it. Yes. All right, and that's exactly what this next thing says. So, and to get this thing to be standardized, to get this mean to be at 0, all right, we see that everything is centered around a mean of 2, which lies to the right of what? 0. All right, so if we subtract the mean from each value, what happens to the curve? So we subtract that 2 from that thing. We subtract this mean value from each piece. What's going to happen? Decrease by what? 2. And if I decrease my mean 2 by 2, where does that mean become? 0. So now, all right, so now if I change this, it's not standardized yet. It's not standardized yet, but now this 2 minus 2, 0. 2.5 minus 2, 0.5. 1, 1.5. So this one is negative 0.5,
Negative 1.
negative 1.5.
Oops, negative 1. Alright,
I see that.
and negative 1.
Okay, so it's not quite standard, or standardized, I should say, because now what's our standard deviation?
No, 0.5.
Our standard deviation is still 0.5. Right? So we need our standard deviation to be what? 1. Well, how am I going to get that? Multiply it by what? 2. Yes. So if I multiply the 1/2 by 2, if I multiply by 1/2 by 2, then I get a needed standard deviation of 1. Right? So make the curve by standard deviation needed. All right. We had the curve of standard deviation of 1 by dividing all the x values by the old standard deviation 1/2. Well, what happens when you divide a value by 1/2? It's the same thing as doing what? Multiplying it by 2. Okay? So when I do that, now when I standardize this, now we have a standardized normal distribution. What you have done is this right here. This is called a z-score. Those of you guys that are taking psychology or have been through a psychology class or plan on doing a psychology class, you'll do z-scores, and you actually, depending on how deep you go, you also go to t-scores. But we'll do z-scores. So now, what this says is to get a z-score, this is extremely important because this question will come on your test. All right? To get a z-score, the z-score is obtained, all right? So write this a little bit bigger so you can see it. Z-score is obtained by taking the x value minus the mean and dividing that by the standard deviation. All right? The old standard deviation, not the standard deviation of 1. All right? So take all of your x values, subtract your original mean, get that, divide that by your original standard deviation. When you do that, you get what is called a z-score. That z-score is now one of these, where this is on a standard normal distribution. So you went from this guy to this guy. All right? This works both ways. This is the hard part. I can give you a z-score, and you can work out the original x value. I can give you the x value, and you can work out the z-score. It goes both ways, and you will have to do both ways. Okay? The good thing about it, it's like your y is equal to mx plus b formula. It works both ways. You can plug it in, you can plug an x into that, you can plug a y into that. You solve for the other one. So these two things are going to stay the same. All right? They're going to be given to you. You're going to be given the mean, you're going to be given the standard deviation, find the z-score, find the original x value that goes along with this z-score. All right? So let's look at something. Now, if I take a look at that first one, we're still using the original normally distributed values with a mean of 2 and a standard deviation of 0.5. What is my z-score for an original x value of 3.5? Well, my z-score is going to be equal to my x value. What's my x value that I'm looking at? 3.5. Minus my mean, which is 2. Divide that by my standard deviation, 0.5. Well, 3.5 minus 2 is what? 1.5. 1.5, oops. 1.5 divided by 0.5 is what? 3. All right? So now, 3.5 on a standardized scale, 3.5 is 3 standard deviations above the mean. Okay? And that's where we get that.
Do you even need the z value?
I'm sorry?
Why do you need the z value? You can just tell how many standard deviation 3.5 is away from 2. By looking at other values they give us.
Okay? So what about 1.75?
Z values.
Oh, now you don't know.
Z value is negative 0.05. But it's 0.05. Yeah, but like.
It allows us to compare that to other values. Where do those other values sit? Let's say something. You'll see. It doesn't make a whole lot of difference when we're just looking at numbers. But when we look at the application, that's when it makes a little bit more sense. Again, trust me, unless you're going to statistics, sadly, this is one of those things that you'll probably never do. I'm just being honest. This is one of these things that you're probably going to do for this test, and then until you sit in the statistics class, you're never going to think about it again. Okay, I'd love to say this is something that you would use all the time, but it's not. I'm not gonna lie. All right. So, how about for 1.75? 1.75, we do the same calculations. So now, 1.75 minus 2 divided by 0.5. So 1.75 minus 2, negative 0.25 divided by 0.5. Negative 0.5. So 1.75 is negative 1/2 standard deviations away from the mean. Now, what's different about that third one? What are we looking at in that third one?
We're trying to find.
What does that P stand for?
Probably.
Probability. So if we're looking for the probability that our x is less than or equal to 0.32, so now, if I'm looking at that, that's the same thing as calculating what probability? Well, I don't look at this, I need to calculate this into a z-score. So instead of my x, I need to calculate that z-score of 0.32, or 3.2. 3.2 minus 2 divided by 0.5. 3.2 minus 2, 1.2. 1.2 divided by 0.5, 2.4. So calculating that probability is the same as calculating the probability. That's equal to 2.4. Okay. And you can verify that. Do your normal CDF. Do the normal CDF for your 3.2. Is that an upper bound or a lower bound? Upper. Okay. So 3.2 is the max. Everything lower. What's my lower bound? Negative infinity. So put in your lower bound of negative infinity. Upper bound of 3.2. What's my mean? 2. What's my standard deviation? 0.5. What do we get? 0.99. Alright, take your word for it. Now, go to this and calculate this. Is this an upper bound or a lower bound? Upper bound. What's my lower bound? Negative infinity. What's my mean? 2. You standardize it. 0. What's my standard deviation? 1. Remember, you standardize this, so we're looking at a mean of 0 and a standard deviation of 1. So now, when we put those values in, we get the exact same value back. So when we calculate this value, it's the same. Like it says. Same as calculating the other piece. So when we're looking for the probabilities, that's when we can do that as well. All right. Now, you got 2 problems for your homework. You're Mr. Ramirez and his tomato farm, and time to go through security checkpoints. That's it. Just takes forever. That's how long it takes.